Hello. Thank you for having me as a speaker today at NDC Oslo, and thank you for turning up. We will talk about real-time applications made easy with Azure Web PubSub today, what this service has to offer. But a little bit about myself, if my clicker decides to work, that is, no, it doesn't. That is because I haven't plugged it in properly. There we go. So I'm Poornima Nayar. I'm a freelance .NET developer, and I am from UK. I live in Berkshire with my husband and my 9-year-old daughter. Work-wise, as you know, freelance .NET developer, but I speak at a lot of conferences, meetups, just to keep up with technology and learn what's new out there. I'm a Microsoft MVP for developer technologies, and I'm also an Umbraco MVP. For those who don't know what Umbraco is, it's a .NET-based open source CMS, and I'm involved in both the communities quite heavily. Something that's not on the slide, I'm a member of the .NET Foundation Outreach Committee, and I'm also a part of the nominations committee this year, so if anyone wants to put forward themselves for the .NET Foundation elections, please come forward, have a chat with me or Joe, who is also in the building today. Non-work me, as I said, I'm a mother. I read a lot. That's my unwinding process at the end of the day. And if that was all not enough, I'm also a student of Carnatic music vocals. I'm working towards like a diploma in Carnatic music. And that's my Twitter handle, should you wish to connect with me. I'll be in the building all day today, and I'll take any questions if you just find me in the corridor or even at the end of the session. So when I think about real-time applications, I think of it as cool and fun and something that puts a smile on my face. And of course, sharing is caring. That's what I teach my daughter. So let me see if I can share the fun that I had trying and evaluating this service, and maybe kind of inspire you to have your own ideas from today and then build on top of it. So let's begin about Azure Web PubSub. It is an Azure offering, and it helps you build real-time applications using WebSockets and the publish-subscribe pattern. So first things first, it's WebSockets. It's your age-old WebSockets that you know about. So definitely, there's a low barrier to entry there. With Azure Web PubSub, there are multiple messaging patterns that you can have. You can have updates between server and all the connected clients, like a big broadcast. You can have messaging between server and a group of clients. You can also have messaging between clients that belong to a group. It's not messaging like individual connections within a group. It's more like publishing messages within a group, completely avoiding the server. So we will speak about that, but in a nutshell, the service allows for bidirectional messaging. A word about publish-subscribe pattern. It is a messaging pattern where you have two entities, publisher and the subscriber. You have the publisher that publishes messages to channels or topics. So that is the terminology when it comes to the publish-subscribe pattern. It's a channel or a topic which can be thought of that as information stream, which is quite specific. Say, for example, you're following updates on a football match, and you have the publishers publishing the real-time updates to like a stream, and that stream is the channel or the topic. And then you have your subscriber, which can choose to listen to topics. So it's an opt-in rather than, hey, I want to push the updates to you. So subscribers have to first opt in to listen, and they get updates for that topic or channel only. There is no constant polling with a publisher-subscriber pattern. It is pushed updates from the server, depending upon what channels or topics the subscribers are subscribed to. And at any point of time, the publishers do not have any knowledge about what the subscribers are or what topics they are subscribed to. So the publisher is like a standalone entity, which means we have loose coupling between publishers and subscribers. It just keeps that segregation or responsibilities quite apart, which is quite nice because we can then bring in scaling to your publishers. And talking about WebSockets, it's persistent connection between the client and the server. And it enables full duplex communication, which means there's data flowing in both directions at any point of time. It's not like a request and a response. Once we have a single TCP connection established, that TCP connection is used throughout the lifetime of the connection. And what makes WebSockets really great for real-time apps is the browser support, plus the support it has over multiple different platforms, as well as programming languages. Any platform that can handle a WebSocket connection in HTTP, the world is yours with Azure Web PubSub and WebSockets. Plus, it is an event-driven protocol. It can listen to events as well. Another reason why it is so good for real-time apps. A typical workflow with Azure Web PubSub looks like this. So you have your server and your clients. You have your Azure Web Pub service in the middle between the server and the clients. The clients talk to Azure Web PubSub service. So when they establish a WebSocket connection, it is with the service that they establish the WebSocket connection. And any communication to the server is just between the service and the server. The service communicates to server, and server communicates back to service using HTTP. So if you're thinking of having like a lightweight service in between your server and your clients to offload all your WebSocket connections, this is the service for you. It is like a dumb messaging service. You can instruct it what to do, and it'll actually do what you ask it to do. And the key concepts and the terms that we need to be aware of when it comes to Azure Web PubSub is, the first one is service. I will call the Azure Web PubSub service probably service from now on, because stand here and tell Web PubSub like 1,000 times, it's not that easy to do that. So it's service for us from now on. We have our clients, which is basically an individual WebSocket connection. So it can be a browser, it can be a tablet, it can be an IoT device, live dashboards, anything that can handle a WebSocket connection is your client. So it's a client connection or a client, various different terms. And each WebSocket gives you a unique connection ID. So if you have 2 browser windows connecting to the service using WebSocket, it's 2 different connection IDs that you get. And connections belong to the user entity, like you and me. And a user could have multiple connection IDs associated with them, and a user has a unique user ID. And then you have your server, which at any point of time talks only to the service, and that is over HTTP, as I said earlier. So which means that your server is completely stateless, and it can scale on demand, plus your service, which is cloud, it can scale on demand as well, which means that we are moving closer towards the cloud-native development, which is very popular these days. Then we can talk about hubs, which can be thought of as like specific areas in a service. So there are logical concepts, so like logical areas in a service, which stands for a group of connections. It's not something that you can specify. The way a hub is formed is the minute the first connection comes in and connects to a hub, the hub is formed. That is the concept. But a hub serves a specific purpose. So you can have a chat hub or a poll hub. Both are mutually exclusive of each other. Despite the same service sharing these hubs, they don't know what is going on in each other. So if you want, you can have that scenario as well. In my demos, I'm using the same service for my applications today. And within hubs, you can have groups, which is a subset of connections. So if you think of hubs like your organizational level Slack instances, you can think of groups as like Slack channels. So just like you can enter and exit a group, the same concept applies here. You can enter a group, exit a group, you can send message to everyone in the group, etc. So it's a subset of connections. You can have multiple groups in the same hub. Again, they are mutually exclusive. And you have to be a part of the group to receive messages in that group. And you can be a part of multiple groups as well if you want. Then you have messages, what goes back and forth between the client and the service. When clients come in, throughout their lifetime of connection with the service, they raise events. So when they connect, when they start messaging, you can even have custom events that you define. All of those raises client events, and the service captures that events, and you can configure event handlers to handle that event on the server side. So the client events are pushed to the server by the service. So the server acts like an event handler that handles the client events and then instructs the service what action to take. Talking about the billing model, some of the terms are unit, which measures the capability of the service. One unit is like 1,000 concurrent connections, and a PubSub service instance can have 1 to 100 units. So that many concurrent connections are available on your service across all the hubs. And further moving on, the hosting plans, you have the free, standard, and premium plans. With free, you have a maximum 1 unit. With standard, you can go up to 100. Premium, which is in public preview, I don't see a maximum limit of units, so which means that it could be like infinite number of units or something you need to speak to your account manager at Microsoft about. I don't know about that. But furthermore, how you are billed. You're billed only on the outbound traffic from the service. So what that means is from the service, the outbound traffic consists of what the service gives to the clients, what the service talks to the server about, and there's also a tool called the live tracing tool, which can be helpful for debugging of what is going on within your service. So all that constitutes our outbound traffic. And plus on top of that, you have a free quota per unit per day, which is like 1 million messages. So if you have 10 units, for each of those units in a single day, you get 1 million messages. And one message is like 2 kilobytes of data, which means per unit per day, you are allowed 2 million kilobytes of data, which is free. And anything over that is what you are charged on. And Microsoft recommends planning for 80% of unit utilization before you start scaling on. So don't wait till all your concurrent connections have run out. This is like the optimal what they suggest. So with that, let us go into a little demo to begin with. What I have is a very simple console application, one publisher and one subscriber. Let us just close all the other windows. Close all of this. OK, so it's not mirroring my screen, which is not ideal. Oh, what happened there? No. There's nothing showing there too. That's bizarre. Duplicate. There we go. There we go. So this is the publisher and the subscriber, just console apps. I'm going to start the publisher and the subscriber. So hopefully it starts and runs. Let me just minimize the window. That's the publisher, and that's the subscriber. So it's asking for something called the connection string, which I can get from the portal. So if I go into the portal and get my connection string, resource groups, talks, and my demo is here. So that's my service, the Azure Web PubSub service. If I go into keys, I'll have a connection string. Don't attempt this connection string because I will rotate the keys in like 1 hour's time once my session is done with. So that's the connection string, using which my clients, be it the publisher or the subscriber, can connect. My publisher and subscriber needs to be in the same hub for them to receive and send messages. So I have put them both in the same hub. Now, if I say hello from my publisher, I'm receiving that. Hello again, I'm receiving that here. But to just prove the point that the subscribers need to be in the same hub, let me bring in another subscriber, use the same connection string. and use a different hub name. So this is the first time a client is connecting to hub 2, so the hub 2 is already formed. Now, if I minimize this and have my publisher in place and have my other subscriber in place, let us see what happens. My subscriber, which is connected to hub 1, receives this, but the subscriber connected to hub 2 doesn't receive the message. So that actually means that the hubs are mutually exclusive. And to see what is going on behind the scenes with this code is console apps, but my publisher has this package called the Messaging Web PubSub NuGet package, which helps with a library which I can use to connect to the service. In my program CS, I'm reading the connection string and the hub name, and I'm creating an object of the type Web PubSub service client using the connection string and the hub. And this is the subscriber. This is the publisher. So I'm creating the service client, and then I can use the send to all method on the service client, giving it the message, which then broadcasts the message out. I don't need anything specific other than the connection string from the publisher aspect to connect to the service, because by nature, publishers are considered as like authorized users, so they can just broadcast to the service. However, on the client side, the client is not connecting to the server. The client is connecting to the service. So it needs a WebSocket connection established to the service. For that, I am bringing in the Web PubSub library as well as the WebSocket client package, using which I can, of course, create the service client. But in this case, I need to generate a client access token, a JWT token, which I can generate using the get client access URI method on the service client. So the URL that comes back has the JWT token, and I can use that to create a WebSocket client. I can then start subscribing or listening to the incoming messages and start the client after that, at which point, if there are any messages, I get everything, all the messages back. So that is publisher and subscriber in a nutshell. So what have we learned from the demo? We can use the send to all method to broadcast any messages to all the connected clients. So this is quite an important one, which I will be using in quite a few demos today. For clients to connect to the service, they need a JWT token, and that can be created using any WebSocket client and the connection string and the hub. But the connection string and the hub that we saw are like secrets, and they should not be shared with the clients. So we need to move that entire JWT token creation workflow onto like a server-side endpoint, and that's what we will talk about later. And before we understand all of that, we need to understand the service internals, which is the server roles and the client roles. So let's talk about server protocol and the roles that the server can handle. The first role that it handles is that of an event handler. So as I said in the workflow earlier, when clients connect to the service and throughout their lifetime of connection with the service, clients raise events. So on connection or on disconnection, when they start messaging, all of these raises events. And these events can be captured on the service. And if you are configuring an event handler, the event data that comes in on the service can be pushed to the event handlers. So the service goes and invokes endpoint, just basic endpoints that you can configure. So the server acts like an upstream webhook in this instance. So if you have configured an event handler, say for message, what the service does is every time there's an incoming message event from the client, it goes and does an HTTP post to that configured endpoint, giving it all the data. And that data is passed using the Cloud Events HTTP protocol, which is like a standard way of representing event data these days. But to keep things more secure, it's not just an HTTP post that it does. There's something called the Cloud Events Abuse Protection that goes on. So before the HTTP post happens for every event, it issues an HTTP options request to the configured endpoint. And during that, it issues a header with a key called webhook request origin, I think. And the value of that is set to the domain name of the service. And on the server side, where I'm handling the event, It needs to send a response back with a header called webhook allowed origin, again with the value set to the domain name of the service. So if the two values match up, then it issues an HTTP post request. So it's not as simple as you see on the eye. But you can, again, make your event handler more secure by introducing managed identity or passing in a code as a part of the event handler URL itself. And to see the event information, an example of the event information, this is how it looks. So the CE prefix denotes the cloud events data or the cloud events information. So that is the role of event handler, handling events that come in from the service. The server upstream can also act as a connection manager. We told about how the server is like an authorized user. So it has access to all the metadata from the clients. So if I go back one slide back, you can see that there's lots of information coming in, the user ID, the connection ID. All of this is available on the server for it to handle. Very useful information. So it can use that information to help the service take a decision on whether the client should be connected, what happens when the client is connected. So the server can instruct the service to, say, message all the clients or message a group of clients or even a specific client. It can also manage the client like, hey, you are coming in to connect. Let me help you connect. Of course, you can connect now. You can disconnect. You can grant or revoke permissions. You can ask it to join group, leave group. All of that is done by the server connection manager role. So when you talk about the server roles and the communication between the client, the service, and the server, the service to server communication is using the event handler role, whereas the server to service communication is using the connection manager role. Yet another role, which I don't have a demo for today, is event listener. This recently came into GA. When I did the same talk at NDC London, it was in preview. A month later, I think, it came into GA. So this is of event listener, whereby you can capture the events, and rather than handling it, you can push it onto event hubs and use the data in a very different manner if you wish to do so. So currently, event hubs are the supported event listener. Azure event hubs are the event listeners. So that is about the server protocol, 3 roles. Then we have the client protocol. There are 2 different WebSocket clients that Azure Web PubSub service can support. The first one is your simple WebSocket client. And there's an entire workflow here in which the server is like an inevitable entity. So there's multiple round trips to server. So you have your client, your service, and the server. The client requests a WebSocket handshake, and at which point it raises a connect event. The service pushes that event onto the server. The server helps take decision on whether to connect the client or not. And if everything goes well, the client is connected. At that point, the client raises another asynchronous or background event called connected. It can be used on the server side for, say, processing, just to know that, hey, I have connected. Then the client can start messaging, at which point it again raises events, which are pushed onto the server. The server does the processing there, and it returns a response. And finally, after some time, if the client completely manages to disconnect, again an asynchronous event is raised to the server. It can be handled there, and then response sent back to the service. So talking about this is typical client-server architecture, where the server completely fulfills the role of event handlers as well as connection management, and every event involves a round trip to the server. You cannot have this workflow without a server in place. And to demo this, I've got a poll app today. So a poll just to mark what's your favorite drink. It's a very basic poll app, but for you to understand where this is coming from. My web pages connect to the server. So what I have is just plain HTML JavaScript pages hosted on an Azure Static Web App. I have an ASP.NET Core web app running with a negotiate endpoint. That negotiate endpoint helps me get the client access token, the JWT token. That is given back to my static web app. And using that access token, the clients connect to the poll app hub in the service. And then they start marking their choices, at which point message events are sent to the server. The server does the processing, calculates the results, and then it instructs the service to broadcast that results to all the connected clients. So that is the workflow here. So let us first see this in action before we go into the code. Let me bring this up. So that's the poll demo. So I'm putting in my name here. So I might have results from before, so just excuse me on that one. So there we go. Poornima joined, and I'm getting the result back because at this point, I have got the client access token from the server. I have connected, and the server is sending, hey, just connect the user who have joined. And when I mark my choices, it is sending another call to the server. It's calculating the results and instructing the service to let all the connected clients know. Now, if I bring in another WebSocket connection, say like so, see what happens. It should say Poornima NDC joined. I can mark, say, water as my favorite drink. I should get the results. And as you can see, both web pages are updating. If I finally disconnect, I can get the message saying that Poornima NDC disconnected. But if I mark my choice here again, I should not see it updating here. So that is it. It's one of 3 here, but it is one of 2 here because I've completely disconnected. I'm not getting any updates from the server. So what happens behind the scenes is I have got this page here, basic HTML, JavaScript. I'm not going to put you through the horror of this because I'm not a front-end developer. It's just basic code. But I'm reaching out to the negotiate poll app endpoint using the ID that I give to generate the access token. And using normal WebSockets in JavaScript, I'm creating a connection and then listening to the messages. But on the server side, there's a fair amount of work going on because what I have is an ASP.NET Core Web API with this package, Web PubSub for ASP.NET Core. And I've got a bunch of minimal endpoints. But first things first, I need to register Web PubSub services into my IOC container. Then I can register a hub using the Web PubSub service client, passing in a type of thub. And when I've registered this to my IOC container, of course, it's there for me to inject into my own endpoints. Then in here, I've got an endpoint called negotiate poll app, which helps me get the client access token. As I've said, I'm injecting the service client here and using the get client access URI to generate the client access token, which is the endpoint my web page reaches out to get the access token. And I also need to define a hub to tie it all up together. So I'm doing that using the map web PubSub hub method, passing in a type of thub and specifying an endpoint of my choice. This method does a lot of work because it registers the hub, saying that this poll app class that I have passed in here is a hub, and it also does the pre-flight checks, that is the cloud events abuse protection check. That's also done here. And finally, if I go into this poll app, what you can see in here is that it inherits from the Web PubSub hub class, which is an instance of a hub. And in this class, I have many methods which I can override and give my own implementation. So in my own message received async, which kicks in for every time I mark my choice, I'm doing some processing, basically just incrementing the numbers. And using the send to all async method, I am sending that result back to my client. And this entire object that I'm sending back is just a plain old POCO, which is registered as a singleton, so that everyone gets the same instance. So that is here. Finally, I need to tie everything up together, like specify that this is the endpoint for my events, and that can be done from the settings. So my class here called poll app, that should be the name of the hub that I specify here. And if I go into my hub, I can see that I've specified a URL template, which is my poll event handler, and the system events and all the user events are being handled for me. There's no authentication, but you can bring in code or you can bring in managed identity, whatever you prefer. So that is the server-side and the simple WebSocket client, but that is not all. You can also have client-to-client messaging like a publish to group, completely keeping the server-side role to very minimum. You can still bring in the server if you want to handle custom events, that should be done. But apart from that, plain messaging, you can do it completely on the client side like a publish. And for that, you have the PubSub WebSocket client. So it's a WebSocket client that supports the service subprotocols. There are two service subprotocols, which is the JSON subprotocol and the protobuf subprotocol. So these are two subprotocols that the service actually supports. That is the Web PubSub service actually supports. And a subprotocol is like a schema or an agreement saying that between the client and the service, they agree that, yes, what I'm going to send you is JSON or protobuf, and you can choose to agree with me on that. So the outgoing and incoming data frames are in JSON or protobuf, but the data itself from the client to the service, that can be plain text, JSON, or binary. So if you have whiteboard apps and things like that, it would be using this kind of PubSub WebSocket client. So this is I'll be using the JSON subprotocol today, but there is also a reliable version of both the JSON and protobuf subprotocols if you want more reliable clients. That is, if there's a network connection drop and then you want to reconnect and still gain your messages back, then the reliable subprotocol gives you a reconnection token as well. So you can connect using that reconnection token and the same connection ID rather than going with a new connection ID. So with this type of protocol, you can have many, many scenarios, like you can join a group, you can leave a group, you can have event information, you can raise events, and you can also send to groups. So in this example, I'm sending JSON data into the group. So the data field is what my message is, so which is the default. You can also have plain text information sent to the group, or even binary information sent to the group. So it is publishing within a group rather than communicating with a specific client within a group. But this cannot just happen all on a sudden, because clients need permissions to perform group-level interactions. So they need permissions to join a group or leave a group or send messages to a group. And permissions are assigned as roles. And these roles can be assigned on clients when you create the JWT token. So when you go into the server, negotiate for the JWT token, you can have roles assigned to the client, and that role information will be a part of the token. Or you can do it during the lifetime of the client as well, depending upon how your app is. And then role names. If you all the role names have the Web PubSub prefix to them, and the permission to leave or join any group is join leave group. To send to any group, it is send group. And if you want to limit it to a per group basis, you can have join leave group dot the group name or send group dot the group name. So that is the permissions and the roles. And if you want acknowledgements from the service for your messages, you can also have an ACK ID in place. So the keen-eyed people might have seen an ACK ID in the examples that I showed. ACK ID is an acknowledgement ID. And this is supported for scenarios where you have clients joining or clients leaving or clients sending message to the group or even custom events. It is totally optional to have that, but it is a best practice, because when you have an ACK ID in place, the service gives you an ACK response saying whether it has been successful or not in delivering or processing that message. With no ACK ID, it's a fire and forget. You can just fire and forget about it. But when you have an ACK ID, you get an ACK response. But when you have an ACK ID, it needs to be unique per connection. So for every connection that I have, it needs to be a unique ACK ID I send every time. Otherwise, the service will reject it, saying it's a duplicate. And this is how an ACK response looks like. It is of the type ACK. You will get a response about which ACK ID it is responding to, whether it's a success or a failure, and if you have any errors, that also comes back. The maximum times I have failed is due to duplicate ACK IDs, so that's something good to know. And to demo this, I have a chat app. It's like a chat room. I cannot have real time without chats because that's the holy grail of real-time apps. Again, we have our clients, in my case, simple console apps, which negotiates the server for the JWT token. The JWT token contains the role information for the clients, using which they can connect to the client chat app hub in the service, as well as join the group of their choice, and then they can start messaging each other in the chat room. But none of those messages actually reaches the server. It is all managed within the service itself for you. So let us see that in action. So that is my client-to-client chat. I slightly changed this demo yesterday, so let's see whether it works. I've brought in the client SDKs. So that's my two users. Let us say user A, and I want to join A. And this is user B. I also want to join group A, because you have to be in the same group for this to work. So hello A. So I'm receiving the message here. So hello again. Hello B. So that is client-to-client communication going on. And this completely ignores the server. You have to take my word for it. But this is what happens using the subprotocol. But to see the code behind the scenes, on the server side, on the program.cs, I have the negotiate client chat app endpoint, which helps me generate the access token. I am again using the user ID, like simulating the authentication, but I'm also having some roles for permissions in place. So I'm keeping it pretty open and giving the permissions to join and leave any group or send messages to any group. And when I create the client access URI, I am using the user ID as well as role information here, which means that the JWT token has knowledge of that. And in my client app, I have this package, Azure Messaging Web PubSub Client, which is a client SDK to make sure that we can make use of this subprotocol. You can bring in just WebSocket clients. So when I did this talk at NDC London, I did not have this SDK in place. I just relied on WebSocket clients, which means there's a lot of JSON serialization going on. But with this library, it is made much more easier for you. So with this package in place, in my program.cs, I have my user ID and the group that I'm asking the client to join. Once I have that, I'm using the negotiate endpoint here to get the client access URI. I can then generate a Web PubSub client based on that URI, which means I already have permissions to join any group. Then I start subscribing to the groups. Then I can start my client, and then I can join the group which I want to join. And using the send to group async method, I can send a broadcast to all the clients just within that group. It doesn't leave the boundaries outside the group. Now, this is just the client SDK that Microsoft have come up with. You can come up with your own SDK as well if you need in your programming language of your choice. But then there's a certain specification that you have to follow, which is, again, in the Microsoft docs. So this is like a standard one, which follows all the specifications of the subprotocols that the service supports. So we spoke about the server, but the real power of it comes in when we start making this completely serverless. So we can have complete Azure Functions integration between your clients, your service, and your Azure Functions. And you don't have to do much about it, because all the server-side functionality that I showed you can be made into Azure Functions with a few bindings and triggers in place. So the first one is the trigger binding. which is what is used for running a function when there is an incoming message from the Web PubSub service. So the attribute here is the Web PubSub trigger. So if you think about the HTTP trigger triggering the function on an HTTP request, this is the function getting a trigger when there is a message coming in from Web PubSub service instance. And the usage of it is for event handling. So event handling is where this comes into real use. And if you want to see an example of this, if you want to handle system events like connect and disconnect, this is what you would start with. So you would have the Web PubSub trigger attribute specifying the hub name, which is where the hub. And you would say the type of the event that you're trying to handle. In this case, it's a system event because it's a connect or a disconnect is a system event. And you specify the name of the event, which is connect. And the type of the request is a connect event request, as you see here. And then I can do the processing, let my clients in, instruct the service to take action, etc. So what I'm trying to do here with my demo here is I have like a simulation of a third-party service, just injecting data into my service. And the point that I'm trying to prove is that using the Azure functions, I can then show that injected data into multiple different platforms. So this is an example of a client trying to connect using Azure functions, using the Web PubSub trigger, and handling system events. If you want to handle custom events or messages, you can again do that using the Web PubSub trigger, specifying the same hub name. But this time, the event type will be that of a user, and you can have message as the event name. You can have your custom event as well. So if you're creating, say, like a game, you might want to take action when probably a character moves forward or walks back. So all that can be created as custom events. You just need to put that in place here and tie it up in the Azure port, in your service side. And the request type here is user event request. And based upon that, I can take the action of, say, send to all or send to a specific client or send to a group of clients, which is what I'm doing here with the create send to all action method here. This one. Can't do that here. So this Web PubSub action is like a base abstract class which contains all the actions it can take. And create send to all is like a broadcast, or you can have send to a particular group or send to a particular user as well. Then you have input bindings. There are two input bindings. The first one is the Web PubSub context. So this is of particular use with Azure Static Web Apps. If you have used Azure Static Web Apps, you might know that it has an app part as well as an Azure Functions part. But the Azure Functions is purely HTTP trigger only. It cannot work with any other triggers. So if you want to run that function when something comes in from the Web PubSub service instance and push information into the app, then you need to use this input binding. So it actually does the purpose of the Web PubSub trigger attribute, but for Azure Static Web Apps. The thing that we will be focusing today is the Web PubSub connection attribute, which lets the client connect to the service, generates the access token. And it is nothing but, again, an attribute that you put in place specifying the hub. And what it does is it gathers all the information it needs to generate the access token. So when you have the Web PubSub connection attribute, it goes and looks for an app setting called Web PubSub connection string. And provided you have the connection string in place, you can straight away return that connection attribute which contains the JWT token. So all you need is that attribute and an app setting in place for it to create that connection for you. And output binding, this is the attribute called the Web PubSub attribute. This is invoking the service to do something. So this is the role of connection management or instructing the service from the server what to do. So you can use this to manage clients or groups or broadcast events, broadcast messages to connected clients or specific clients. All of that is done via this output binding. So broadcasting to clients, so I have brought in the Web PubSub attribute, which is my output binding. And then using the Web PubSub action, I can then do the create send to action, using which I can broadcast a message to all the connected clients. So let us have a look at what happens underneath the hood. Let us go have a look at the function itself. It should have a configuration. The Web PubSub connection string, this is the connection string that I'm using for my Web PubSub service, and this is like a convention, a naming convention that it follows. So with this connection string and that particular name in place, the attribute works out the connection string, and using the hub name that you provide, it works out the connection string and the JWT token. And in my service, if I want to make use of an Azure function as my endpoint, which I am doing here, it needs a extension key or a code. So that when you have an Azure function with the bindings and triggers in place deployed, it creates an extension key for you by default, which is, I can't remember where it is, but it is in place, and that code is used here. So the extension key that you get with a function, that needs to be used for authenticating with the function. And as before, I need to configure my event handlers, and this is where I do it. So I think that can be, it's one of those days where I've forgotten. There we go. That is the Web PubSub extension. So when you have a function with all these triggers and binding in place, it generates the key for you, which you can use. This is the same key that I'm using here to connect my service hub to the Azure function and use the Azure function as the event handler. So what I'm trying to do here is I have got this send to Web PubSub client app, which is going to just inject weather information, like random weather information, to all the connected clients. So this is passing a lot of information to the service. So it's like simulating a third-party app, which is sending information to the service. And that service talks to my Azure function. And I have two other clients, which is a Blazor app, which is what I have here. And provided that runs. Come on, come on. There we go. Is that the Weather Hub app? That's the Weather Hub app, and it is connected and is ready to receive data. There we go. This is the information that I'm sending and the information that I'm getting back on the client. I can bring in another client if I have, say, the stream client again. That should get the information as well. So that is both my services, both my clients getting the information from a third-party app using a service which talks to Azure function, and these two clients are connected to my service as well. So that is what is going on beneath the scenes. Now, let us talk about some of the other stuff. That is all the code done for the day. You might want to occasionally debug and see what is going on in your service. For that, you can bring in resource logs. And to see what is going on in your service, if you go into the live trace settings, there is the live trace tool. You can't really see what is the message that is happening, but you can see that, hey, I'm receiving information. There is something being sent to my service here. So that is what you can gather from here. This also is a part of your outbound traffic from the service, so you will get billed for the usage of this. So currently, I've got both my clients running, which is the reason, one of the reasons that I have information coming, because the hub name is Weather Hub. I also have like an Azure function running, which with a timer trigger, which just sends out random data into the service. So that is in the notification hub. So I can see multiple hub information in the same resource logs as well. Now, what are the benefits of using this service? You have a built-in support for large-scale real-time applications. Of course, it's WebSockets, so you have multiple platforms, various programming languages with a low barrier to entry. You have Azure Functions integration, as you have seen, so you can make it completely serverless and pay for your usage. And of course, the various messaging patterns. Use cases, wide variety of use cases. If you go into the samples, you can see a lot of examples as well, starting from browser apps, chat rooms, IoT, live dashboards, gaming, collaborative whiteboard apps, all of that. Now, Azure Web PubSub service is not just the only service out there which you can use to build real-time apps. You can have SignalR. You even have Azure Service Bus, each of which differs. There are other third-party apps as well, which I haven't used, so I'm not in a position to comment over it. But a comparison between Azure Web PubSub and SignalR service, when to use one over the other. If you want to have WebSockets in place, then go for Azure Web PubSub. If you want a simpler messaging pattern like what you have seen today, then Web PubSub. If you want to offload a bunch of WebSocket connections to another service and free up your server, again, that is Azure Web PubSub. If you want client-to-client interactions, again, Web PubSub. With SignalR, you can bring in more complex messaging patterns like RPC or streaming capabilities with fallbacks in place. Plus, another thing to notice here is that with Azure Web PubSub, you don't have presence information, like if a client is online or not. You don't get that information. If you want message queuing, you need to bring in Service Bus, but I think message queuing is available with the reliable JSON protocols, but that is still in preview. But you don't have message history for replay. Unless and until you store it elsewhere and bring that data back in, it is a lot of work. And what about customer data? Nothing happens to customer data because Web PubSub doesn't store any customer data. It is just a messaging service. It just acts according to your instructions. And that is it from me today. Web PubSub, that is the resources URL. Most of it leads to all the Microsoft documentation. Have a play around with this service. I hope I've inspired you enough through my episodes to go and build something of your own. Yeah, this is a service that's been there for about 2 years in general availability, and there's a wonderful, wonderful demo in the resources. I think Anthony Chu did a demo about Azure Static Web Apps and Azure Web PubSub, which I regard as the god of all demos till date. Like, it's the best demo I have ever seen. So go have a look at that too in my resources. You will be wowed. Thank you very much. Any questions, just catch me now or later. Thank you.